Okay? But then piled on top of that is about 800 kilometers of ice. Okay, so then you take our moon, you add this huge ice layer on top, and then on top of that, you have about 1,000 kilometers of atmosphere piled on top of that. And the atmosphere is mostly nitrogen, just like the Earth's atmosphere. And this atmosphere is huge. I mean, if you did a little onion skin diagram like this of the Earth, the atmosphere would be like this teeny little line, right at the surface. Here we have this huge, massive, extended atmosphere around Titan. It has about 10 times the mass of the Earth's atmosphere.
Does that mean that Titan has to have a lot of gravity to hold that atmosphere?
Yeah, although we've observed, we know from its size that gravity is maybe about actually it's similar to lunar, maybe a little bit more than moon, 1/5 to 1/6 Earth gravity. And gases will escape off into space. I mean, they're escaping from the Earth. Earth does hold on to most of its atmosphere because of its gravity, but they do escape faster from Titan. In fact, we do see a lot of gas streaming off from Titan when we've flown by with Cassini. So something seems to be resupplying the atmosphere from the interior. Or there's some kind of buffer that's keeping the atmosphere there. And all we've known about Titan until a couple of years ago came from telescopes and came from when Voyager flew by in 1980. And when Voyager flew by, we found that it had this nitrogen atmosphere, 95% nitrogen, but then the next constituent in the Earth's atmosphere is oxygen. On Titan, it's sort of the opposite. The next constituent is methane. Okay, it's like natural gas mixed into this nitrogen atmosphere. The methane isn't going to burn in Titan's atmosphere because there's no oxygen there for it to combine with, but I've actually worked it out once that if you combine Titan's and Earth's atmospheres together, they would exactly burn each other up and there'd be nothing left except nitrogen. Some of the surface that we're able to see on Titan is icy. But the problem is we can't really see the surface with optical cameras because it's covered with this thick orange haze in the atmosphere. And this haze comes from chemical reactions from ultraviolet light hitting methane, breaking it down, and starts combining together into new organic molecules. And it's called photochemical smog, which you might be familiar with because this happens in American cities where you have volatile organic compounds going up from tailpipes. They get hit by ultraviolet light from the sun, they combine together into brown, choking smog. This is happening on a planet-wide scale all over Titan. And Titan is a favorite baby of organic chemists because this means there's all kinds of interesting chemical reactions going on in the atmosphere, and there could actually be liquid hydrocarbons raining down on the surface. This is like oil companies' dream, you have plastic and natural gas and diesel just raining out of the atmosphere. It's wonderful. But astrobiologists are excited too because you could have prebiotic compounds that are also raining down into the atmosphere. And we didn't know what we would find on Titan because Voyager pictures showed nothing but a blank orange slate. And so some people ran away with these atmospheric chemistry models, and they said, well, Titan should be covered with this global sea of liquid hydrocarbons just covering the entire thing. And this is what it would look like. You just kind of have this, sludgy brown sea, and then the orange sky above it, it looked like Houston. And this view, though, started to be changed in the mid-90s when the Hubble Space Telescope actually found that there was a little infrared window where you could see through the smog down to the surface. But Hubble is so far away, all they could see that there was just a bright blob on one side of Titan and dark blobs on the other side of Titan. So we knew at least it wasn't globally covered with the sea. But they said, well, this dark stuff here, that's the sea, right? Yeah, okay. We still had to figure it out. But we want to get down below that atmosphere. And Cassini has 3 different ways of doing that. And I'll show you all 3 ways. One is it has a camera that can see into these infrared wavelengths where you can see through the smog down to the surface. It also has a radar that penetrates through the smog and maps the surface. And then it had a Huygens probe that actually dropped down into the atmosphere and landed on the surface. So this is an infrared picture of the surface, and this is where in that Hubble image there was a bright blob here, and this was a dark blob here, and so the hydrocarbon C proponents on Titan were like, oh well, this is the C here, right? That's the big dark thing. Kind of looks like a C.
Right.
As we zoom in closer, you can't kind of imagine like islands in this dark, goopy sea. Here we're getting even closer. There's a 100-kilometer scale over there. So this is we call this Great Britain for
England, yeah, that's England.
obvious reasons. But then we started getting radar data back and started seeing what does this dark stuff look like in radar. Turns out this dark stuff is composed of all these little streaks in the radar. I'll show you a better picture of those later. Another thing you might notice in this picture is these little windy branching things. Does that look like anything?
Drainage channel.
Yeah, they look like drainage channels and stream valleys. Exactly. Here's another picture of some of those dark streaks covering the surface. Turns out that these dark streaks are an exact dead ringer for longitudinal dunes on the Earth. It's this kind of dunes that you get in super arid, giant desert areas where you have a lot of sand. Here's a Google Earth image from southern Libya where you have these big, long sand dunes all marching next to each other, and it looks just like the surface of Titan. And on Titan, they even go around little topographic obstacles and have wind shadows. So this hydrocarbon ocean, it turns out, that big dark thing on Titan turns out to be a sand sea instead. It's covered with dark sand dunes all over the surface. So it might be that you have this sort of bright ice and then dark sand dunes of dark, solid organic material. Maybe it's even like little plastic pellets that have been formed out of the atmosphere. We don't know what the sand is made of yet. But where did this hydrocarbon ocean go? Problem is, this ocean was one of the things that people were depending on to sort of resupply the atmosphere, that you would evaporate liquid out of the ocean and that would resupply the atmosphere, and that's why you still have one on Titan. So, is the atmosphere recent? I don't know. One thing we haven't found on Titan is craters. We found 3 craters so far, and we found about 5 suspiciously circular features that might be craters, but we're not sure. Here's one crater called Simlap. Here's another called Minerva. So Titan seems to have been completely resurfaced somehow. I mean, the slate has been wiped clean, and there's only a few impact craters on the surface. So why so few craters? Why only big ones? Is another question. And this is, where we have to say, wait a minute, Saturn system's really weird. Some of the satellite surfaces are really old, but we have a lot of young things going on, like Saturn's rings don't last very long. Dione, Tethys, and Rio were all recently fractured. Enceladus, something big is going on right now. Titan's atmospheres, maybe that's a new phenomenon too, and certainly there must be some activity going on in Titan to do this. So what's going on here? It seems like maybe the Saturn system seemed to be quiet for a long time, and then something happened that's sort of gotten all of the satellites agitated and gotten all this activity going. But what? That's the big question. And I'm not even going to speculate on that. But I just wanted to put that up there because one of the big unanswered questions about the Saturn system is that it's not behaving like a lot of the other systems that we see. Maybe those rings are telling you something. Maybe the fact that Saturn has those rings and none of the other giant planets do is telling you that something happened at Saturn that didn't happen anywhere else. But I want to get to part of Titan that I really find exciting.